All right. Good evening, everyone. Going to go and talk about some more details about voting and the voting system, and that we are, talking about. You might have seen our previous video, Vox Part 1 of N, because I don't know how many segments this is going to take, but this is segment 2. And so in the voting system that we're talking about, one of the things is we want to have a auditable voting system. So that means we need to be able to have a paper trail, proper paper trail. And for this demonstration, there's a whole bunch of assumptions that are baked in here, assumptions that I feel like are fairly reasonable. We have a trustable voting terminal, and even if the voting terminal is moderately trustable, we're going to generate a document that contains the answers to the ballot, represented both electronically and physically, and then we'll talk through the process of how that would get turned in or returned in or shared with the thing. So this is an oversimplification. If it's a proper balloting, voting, election kind of terminal, you would have a system that presents you the questions on the ballot in a nice way and lets you select one or more of the responses to the ballot, with some nice visuals on there. You'd also have some assistive technologies for folks who have vision or hearing issues. Those are handled today on a paper ballot. Lots of times folks will have a trusted party help them register their vote on a paper mail-in ballot, for like public elections. And then if you're talking about private elections, and when I say private elections, I mean things like HOAs do private elections, sometimes organizations of varying types. This company will do it, or the trade unions do what I would call a private election. It's not an election for some kind of public office. It's just an election that we want to run for our, like I say, an HOA, for our union. Those are the ones I can think of, that I have some experience with. And one of the things I've done here too, I want to test the system to see how much of this stuff could be handled. And I did some motivated interneting, and I found this ProPublica article about Miami-Dade sample ballot general election, 12 pages. It seems to be like that is a long time. It's even telling that they were saying 70 seconds. Oh, hold on. I'm not sharing my screen with you. Let me go back and share my screen with you. Okay, now I'm sharing the screen. Again, back to, we want to do something with a complicated ballot, or at least I'm wanting to show two things here. One is, here's how to make a piece of paper that can also be easily read, electronically and fairly accurately. With, of course, some trust in the electronic system, but with the backup of, oh, yes, the same data is represented, in plain text. So humans could do a plain text count or, view. So I did some searching. I found a complicated ballot for that specific thing, and Miami-Dade has a 12-page ballot. And they were saying it takes 70 seconds to print. That's quite a long time. I don't actually have a printer with me right now to do any test printing, but I can maybe see how I can figure out how to do something like that. Okay, so let's hide this little thing here. That's the something or other. Let's do the sample real quick. This would be what my ballot looks like, and we have question 1 on the ballot, and I would have my answer. And then I would have question 2 on the ballot, and I would have, answer 2. And these are contrived examples. And I would have question 3 on the ballot, and I would put in, somebody's name, Joe Q public, right? These are the people that I'm voting for. And then in this universe, Vox, the Vox universe, I would make a PDF document straight away. And this is my balance, the response to my ballot. And I have answer 1, answer 2, and answer 3. And then we have this sort of checksum piece at the end, this response bundle, which is these previous answers, all assembled into one big bundle at the bottom. So you can sort of use that as think of it as like some kind of checksum. And this example is oversimplified on purpose and is missing some of these other features when this is run in a more serious, in a more professional way, right? We're just doing some examples on the YouTube. But one of the other things I wanted to sort of put together was try to put that complicated ballot together. And I have that 12-page ballot right here, general election ballot, and it's in 2 languages. And look, this is a lot of questions here. Part of it's what's taking a long time to print out is that we have some of these questions are, they have a whole lot of text of the questions, and this is in multiple languages. If you're issuing an electronic ballot and you're issuing an electronic ballot, through some kind of application, obviously the voter would be selecting their language ahead of time. So you wouldn't even end up having a 12-page printed mechanism, and you would have a shorter one. But this one does have what we wanted to show is a lot of questions. And let's see how I can do this side by side. I can maybe stack that there and stack that there and get rid of that thing and say fit to width. And now this kind of works. And we would have the president. I'll just call it Q1. And then that's the president and vice president. I'll just pick the first one on each of these. Mitt Romney. Romney. And then Q2 looks like it's for the senator, and it says Connie Mack. And then Q3 has Congress District 23, Karen Harrington. And then we do Q4. So this text that I'm writing in here is something that would be assembled through, the web interface that goes to put all of this stuff together. So the question 4 is District 25, Mario. Question 5 is David. Question 6 is that probably is Ileana, and Q7 is Catherine, Katherine. That font is very small and getting difficult for me to read. Let's see, after Catherine, I'm going to pick this guy, John. And then on Q9, we're going to pick Scott. And then on Q10, we're going to pick Sharon. And on Q11, we're going to pick Manny. And on Q12, we're going to pick Carlos. And Q13, Barbara. Q14 is Jose. And I'm going to just leave it all in lowercase so it'll go faster. And then on Q15 is Eddie, and Q16 is Alex, and Q17. This is one of the more complicated ballots I've had to put together. So let's see, that was Alex. So then it's Eric. Whoops, here, Eric. Oh, I wrote A. I meant to have Q18. It doesn't really matter for this thing, it is just an example, but in these responses, we want to have responses that sort of indicate the question that they came from and what the answer was. And we could possibly should, put something like president and vice president, like this. Might want to put that on each one of these things. Anyways, all the way down here. I picked Eric, so now I'm at District 115. Something to point out here too, for the example, which is different than how things work in real life, especially for this public general election. I wouldn't be voting for District 14 and for 15 and for 112 and for 116, right? You would only be voting in one of these at a time. So in actuality, you're not going to answer this many questions on a ballot. You would be answering, a smaller number of questions on the ballot. And, to be frank about everything, when our system is recording these things in, our production environment, if we're hosting a real election, each one of these questions is assigned an identifier, not Q1, not Q2, not Q3, but they're assigned like a 2-character alphanumeric identifier. So this question might be something like, AA, and this question might be something like B4, etc. We've got a bunch of different options right there. For anybody who cares about the guts of the details, that is a, integer value that has then been base 32, Crockford base 32 encoded. Well, they just pick Eric, and so then I would pick Michael, and then I'm gonna just start doing those alphanumerics now. I didn't do AB yet, did I? No, AB, and then I'd pick Jose, a different Jose, and then AC would get KIONNE, I think is what that reads. It's hard to see all of these things. Holy dolly, is this getting to be a mess. And then it's Frank. Frank didn't have any opposing. And then it's Jen, ETTE, AF is Holly. EFG would be, let's see, should I vote yes on everything? I'll just fraud back and forth. Yes. H is no. Then yes. And then a no on District Court of Appeal. And then a yes on the other District Court of Appeal. And then a no on this one. And then a pick yes. And then I pick no. And then I pick Greer, Elaine, Wallace. Greer. Then I pick Audrey. That one gets skipped too. Forgot about that. So I'll just delete that one. And then this P will become a yes. And then actually Q, I'm trying to do this manually, and it's difficult to do manually. That's why we have like a computer that handles this for it. I forget about it. And then AR is Bruno. And then Manny. And then Natalie. And then a V is Curtis. W is Sonia. Gina. Oh my goodness. And then now we have these long questions. Number one, yes or no? All right, I'll just say yes. And then on number two, I'll say no. And then here we have this is actually, now we have Q3. I'll just start calling them no 3 question mark. What did I just say? Yes, number 4 will say no on whatever it is. Number 5, I'm going to say yes on. Oops, got some bullshit in there. Number 5, number 6, I'll say no on. This part is pretty tedious, and I'm sorry, but we just want to show off like that it could go this far. Number 6. Number 7 seems to be missing. So we have number 8, which is a yes. And then we have number 9, which is a no. I've typoed these things, but again, it doesn't matter because we're not connected to any of the rest of the database. This is just the example of lots of questions and answers and producing a piece of paper that can print that out. Number 9. Number 11 is a yes. Number 12 is a no. Oops, I missed number 10. Number 10, I'll just do yes again. Why not? I'm such a positive guy. Number 12, is this all still number 12? No, then we've got, oh man, school question. I'll just say it's S1. 4, S2 is no, S3 is yes, S4 is no, S5 is yes, S6 is no. Damn it, this is a lot of stuff. Oh, I'm almost done. So I've got 1, 2, 3, 4, 5 more to go. Sweet. Thanks everyone for hanging out. Number 12, number 13 is yes. Number 14 is no. Number 15 is yes. Number 16 is no. Number 18 is yes. I'm just skipping stuff. So what happens if I create a PDF? Well, there it works. And it says President and Vice President, these goobers. And then here's all the rest of my questions answered nicely, very clear. 1, and this thing. Now, again, in the real world, when we're running a production one, these responses show the whole question that is being asked and then the answer that was given. The QR is actually just encoding the given answer. And then all the way down here at the bottom, this is probably too damn small to see or read reliably, but there's the response bundle, and that is a, you know, nasty QR code that contains probably way too much data for this thing to really be comfortable using. Let's create the PDF again. Run through here. This is all just some client-side JavaScript. Yeah, so ran into a problem. Oh, I know what the deal is. It's not clearing cache. Oh, you're making me look bad, computer. 559 characters in that blob. Oh, let's see. I just turned the debugger off and then everything works real swimmingly. Okay. So this summary down here, this nasty QR is about 600 characters that have been recorded in there, you know, showing the result of whatever that QR, whatever the summary of everybody's data is. You know, let's even see if this is readable. I got a proper QR reader. I can't read it off of the screen, which is sort of to be expected because the screen is so, it's reflecting and whatnot. And this QR is very, very dense. So that part's not going. But if I scan one of these, oh, there we go. Number 18, yes. Let's see if we can try this one again. No beeps means it's having problems reading it, but then we can scan these other ones, put them back to their proper size. And there I can see, oh, it got the whole bundle. Hot dog, it is readable. I guess it was just having to do with like the size of the screen or possibly some reflections, you know, in my room. It's dark here and things of that nature. But you can see this was me scanning the result of just one question. And then right here is that huge long bundle of everything that we've answered before. It has the responses to a question. And then these QR codes got limited character sets. So we just take this QR code and separate everything with $1. And so now you've got your question that was asked off of the ballot. And then you've got the little bits here. That's the, you know, for the next one, we've just shortened all of the questions to what they would be, you know, in the universe. And then you've got an answer like this. Now, this response was about, what did I say? 560 characters. And the universe tells me that I should be able to put a response that actually has more characters than that. I should be able to put one that has, what's the word I'm looking for? Should be able to put it, I'm trying to write code and think at the same time, which is difficult for me at best. So we're going to do this, and we're just going to make this next QR like larger. Do something like that. It does try to vertically center it. Take all these responses again. I'll reload my page. I'll paste in that bullshit response. Now I've got everybody. And then if I get down to the bottom here, oh yeah, I got a huge QR code, which I've done on purpose. And if we look, it's still only 599 bytes. But let's figure out how to do something there, because not everybody has, not every answer is going to be short like this. This is like a long answer. How many characters is this answer? That answer is 40 characters. And I wonder, I forgot to count how many answers there are. I'll do a little more logging right there. This thing renders poorly when it is in debug mode. So just, bear with me on stuff like that. Oh, well, I've fat fingered it. Come on, give me a mo, because it's debugging right here. And I'll just paste those answers into the text area so I don't have to keep doing that. Ugh. So this one has 60 answers. That's how many answers we have. 60 answers. Boom, there we go. That's our 60 answers. But now what if I have 60 answers that are, all 40 characters? Of course, most of them won't be 40 characters. So that gives me a spot where I'm going to end up with 2,400 characters as my response, right? So let's try that, right? I'm going to do for each answers. I'm going to say this, like, answer 0. And then I'm going to say it becomes this. And I'm going to just say, going to reassign the answer on every single one of these. And, let's just reload the page. I'm going to hit create PDF. Oh, it does not like me. Sort of unhappy about something there. Wonder what the deal is. Could that be it? Oh gosh, this freaking debugger. Boom. All right, so there's my 40 answers. There's my 60 answers where each encoded segment is 40 characters. So this is like a lot of data that gets recorded. And then all the way down here, I've got this too freaking large bundle that is my the data about the QR code that's been recorded. I am not really helping myself make a lot of sense right there. But that's not what it is. And that's for the whole bundle. And then I'm going to write the word response bundle. And then I'll just do something like this ought to do it. Close this out. Why are you unhappy? There we go. Again, hung up on the debugger. Now I've got this huge thing, and I just like robbed the font so I don't have to like look at it getting in my way. Sort of bothering me. So there's our nice big QR bundle. I wonder if it's scannable. Let's give it a shot with the QR scanner. Yeah, that one's having some difficulty reading, probably because it's ever so dense. And I'm trying to read off of my screen. You know, reading off the screen is not really what these kinds of things are designed for. You know, we'd be scanning off of a piece of paper. Maybe on the next go, I'll come back around and show you, oh, here's how we can get this off of a piece of paper. I'll get my printer rigged up so that kind of thing can go. But right here, this is a brief demonstration of a ballot that can get created, a ballot result that can get created that has an electronic record. And then, so this means it's easy for electronic tally systems, so we can get the result quickly. But it's also got the answer that the voter selected right here. And then how do we know that this whole thing is like good and legitimate and things like this? Well, similar to, you know, a regular ballot or something like this, you've got this thing sealed and you've got the wrapping envelope signed by a specific voter, you know, so they could, you know, the theory of operation for a public election and the way that things work for, you know, a private election, which generally does not have 8 pages of results. Generally, we're on 1, sometimes 2 pages of results. And so the voting booth in that scenario is, well, you know, in the corporate scenario, folks visit this website, they select their choices for the voting, they press the little button, it generates the PDF, they print out this PDF. Maybe they're working from home and they print out this PDF. They put that in an envelope, just like a regular, you know, public ballot, and then put that in the other envelope that they mail in to, well, to us or to maybe somebody else they have that's using the same tooling to execute, you know, the tally of what those election results are. If this was like a public election, you would maybe go to the registered polling facility and use the trusted terminal in the polling facility and press some buttons in there to generate the document. You're obviously not going to be hand entering these kinds of things in there. And as I get further down this whole here, let me show you what I'm talking about stuff, will have more of the other guts of the system and some, you know, things that would count for a user interface. Here's how to click through. Here's where you select your ballot. Here's how you can show up and register. And here's how you can redeem, and a bunch of other stuff that gets complicated, very complicated when you talk about public election. But in private election, you know, you've got simpler bits. And again, people trust their own computers reasonably well for this kind of thing. And even if they don't, you can see what they've selected right here. Other mechanisms that happen once you've mailed this piece of paper in to whoever it is that's doing the tally, they've got your pieces of paper. They can tally up your results. And, in some of those, these ballots are anonymous, but you have your own little magic sequence of your ballot identifier that only you should know. And you would be able to use those things. Whoever the voter was, they say, oh, let me go and look at the tally. The tally says, that Joe Q. Public got voted as a treasurer. Let's go and look at this tally result, and you can see that in real time, and you can go and plug in your secret code and see, oh, well, look, my vote was counted. My tally was this. The summary system, if I look at the tally results that other people are looking, and this way, the results that show up and get recorded electronically, translated in from these pieces of paper, can also then be downloaded by anybody who wants to check the integrity of this kind of stuff. So whether that's, other union members, whether that's other shareholders in the company, or, some other homeowner in the HOA says, I don't believe, number 7, I don't believe they could have won the election. Bill's a jerk. And so, well, let me download the results and you'd be able to see this. Well, here's all these tally numbers, and, here's the summary, and here's the votes that are collected. And anybody who wanted to check their own, can you go into the tally system, with their special magic code and look themselves up. If somebody else guessed your special magic code, they'd be able to know what that magic code voted, but they wouldn't know who that magic code is associated with, part 1. And then part 2, guessing these magic codes is rather difficult. For the nerds out there, we're talking about like 40 bits of entropy, for any given election. So 40 bits of entropy, 40 bits of an identifier there, that's a big number. Hella big number, very large number. And let's see what my calculator tells me it is. What do I say? 2 caret 40, 1.9 and 12. What does that mean? It's 1 with 12 zeros at the end or something. So is that billions or is that trillions? Anyways, for all the math nerds out there, very, very big number. And when I only have a couple 100,000 shareholders or tens of thousands of union members, or I've got hundreds of people in my HOA, this is a harder for somebody to, guess. There was this cool webpage I saw that lets you plug in, well, how many bits do you have in the thing? So how hard is it going to be for somebody to guess if you have 40 bits? And it's like, a very, very, very long time. And even if they could guess one of those codes, you don't know who those codes are assigned to. We'll come back in part next one, or maybe the next one, and talk about magic code redeeming and magic code tally and how that part system works. Because like in part 1, we talked about the registration system a little. Maybe I should make more noise about that registration system and how you get your own little magic code for your voting and how that works for, varying classes of elections, So thanks. That's another little rant about how some voting systems works. Thanks for hanging out.